Hello everyone, myself Dr. D.M. Chavan, Assistant Professor in Chemistry. Dear friends, I welcome to all of you into my YouTube channel Vidcam. Please like and subscribe my YouTube channel to the others. Dear friends, in the previous lecture we discussed about the aldehydes and ketones, their preparation, their geometry, their polarity, and the acidity of alpha hydrogen atom, their structure. In this lecture, we discuss about the reactions of aldehydes and ketones. The reactions of aldehydes and ketones are also known as the name reaction. As these name reactions are of different types, we discuss some of the name reactions of aldehydes and ketones. These name reactions are very much important from the synthetic point of view. So, we discuss one by one. First, we discuss the name reactions of aldehydes and ketone, that is the Cannizzaro reaction. Dear friend, this Cannizzaro reaction is the reaction was given by the Italian chemist Stanislao Cannizzaro in 1853. Hence it is known as the Cannizzaro reaction. In this reaction, when two molecules of aldehydes which does not containing the alpha hydrogen atoms when we heated in the 50% NaOH, then we get one molecules of the aldehydes get converted into the formate and another molecule get converted into the benzyl alcohol. Suppose this is the first molecule of the formaldehyde, then second molecule of formaldehyde, then we heated it at the 50% NaOH, then we get the sodium formate along with the ethyl alcohol. Now we discuss another type of reaction, that is the Crosschain reaction. In this reaction, two different aldehydes does not containing alpha hydrogens are heated in presence of concentrated alkali called as Crosschain reaction. The only difference between the Cannizzaro reaction and Crosschain reaction is that in the Cannizzaro reaction, the two aldehydes use their of same, but in the Crosschain reaction, the two aldehydes use are different. For example, one is formaldehyde and another is benzaldehydes. Both these aldehydes does not containing the alpha hydrogen atoms when heated in 50% NaOH, then formaldehyde converted into the sodium formate and benzaldehyde converted into the benzyl alcohol. This reaction is known as the Crosschain reaction. Then next reaction is the reformation reaction. In this reaction, aliphatic or aromatic aldehydes and ketones reacts with alpha bromoester and zinc metal in presence of dry ether gives beta hydroxy ester. This reaction is known as the reformation reaction. For example, this is the benzaldehyde. When this benzaldehyde is heated with the alpha bromo ethyl acetate, why it is known as alpha bromo ethyl acetate? This carbon is the alpha carbon atom, and to this alpha carbon atom there is the attach of bromine atom. Therefore, this molecule is known as the alpha bromo ethyl acetate. Then this alpha bromo ethyl acetate when heated in presence of zinc and dry ether, then bromine attacks on this oxygen atom, and first we get this intermediate complex compound. This intermediate complex compounds on hydrolysis, that is addition of water, then this oxygen zinc bond get break and it converted into the beta hydroxy beta phenyl ethyl propanoate along with the elimination of this complex zinc. Then Perkin reaction. What is Perkin reaction? Perkin in 1868 given the reaction is known as the Perkin reaction. In this reaction, aromatic aldehydes when heated with anhydride of aliphatic acid containing at least 2 alpha hydrogen and sodium salt of same acid, there is the condensation takes place to form alpha beta unsaturated acids, and the reaction is known as the Perkin reaction. Consider the benzaldehyde. When this benzaldehyde is heated with the acetic anhydride, this acetic anhydride contains the 2 alpha hydrogen atoms. One is on this carbon atom and another is on this carbon atom. When heated in presence of sodium salt of same acid, that is the sodium acetate at 180 degrees Celsius, then this carbon attack on this carbon atom on the carbonyl group, and we get the cinnamic acid, or it is known as the alpha beta unsaturated acid along with the elimination of the acetic acid. Then we discuss The mechanism of Perkin reaction, how the alpha beta unsaturated acids are formed in the Perkin reaction, can be well explained by studying the mechanism of the Perkin reaction. In the Perkin reaction, this is the catalyst, that is sodium acetate. It flips as acetate anion and sodium cation. This acetate anion generated attacks on this acetic anhydride and it withdraws this hydrogen as a proton by attacking on this carbon atom to affect the alpha hydrogen atom, and there is the formation of the carbanium. In the second step, carbanium attacks on carbon of benzaldehyde to give the intermediate anion B. Suppose this is the benzaldehyde and this is the carbanium generated in the step first. What happens? This carbanium attacks on this carbon atom because this is the electron deficient carbon atom of the carbonyl group, and it gets converted into the intermediate B. Then step third, anion B gets protonated by acetic acid formed in step 1 to give the intermediate C. It loses water molecule to form alpha beta unsaturated mixed anhydride D. Suppose this is the B. B on protonation it produces the C. The C on undergo the rearrangement by elimination of water molecule. The C undergoes the rearrangement by elimination of water molecule and produces the alpha beta unsaturated anhydride D, and this get hydrolyzed to give the cinnamic acid. This is the D, and this D on hydrolysis it produces the cinnamic acid, that is also known as the alpha beta unsaturated aromatic acid, along with the elimination of the acetic acid. Now we discuss the next reaction, that is the managed reaction. This is again another type of name reaction. In this name reaction, that is managed reaction, aliphatic or aromatic ketones containing alpha hydrogen will react with formaldehyde and ammonia or primary amine or secondary amine, use beta amino ketones called managed base, and reaction is known as managed reaction. For example, acetone, when heated with the formaldehyde along with the dimethyl amine under the acidic condition, there is the elimination of water molecule and it produces the product. That product is known as the base, and the reaction is known as the managed base reaction. In this reaction, there is the formation of 4-dimethyl amino 2-butanone. This product is known as the managed base, and therefore this reaction is known as the managed reaction. Then aromatic ketones such as acetophenone undergo the managed reaction. For example, this is acetophenone when it is treated with the formaldehyde along with the dimethylamine in presence of methyl alcohol and hydrochloric acid. There is the elimination of water molecule and we get the formation of the managed base, that is 3-dimethylamino 1-phenyl 1-propanone. This is the details about the managed. Now we discuss the benzoin condensation reaction. What is the benzoin condensation? Aromatic aldehydes do not containing alpha hydrogen, and treatment with alcoholic potassium cyanide or sodium cyanide undergoes condensation to give alpha hydroxyketone called benzene. This reaction is known as benzoin condensation reaction. Consider the benzaldehyde. This benzaldehyde does not contain the alpha hydrogen atom, then reacts with the another molecule of benzaldehyde, and when we heated it in presence of the potassium cyanide or sodium cyanide, then there is the formation of the product benzoin. This product is known as the benzoin product. This product contains both the functional group, that is the carbonyl group and hydroxy group, and the product is the benzoin, and the reaction is known as the benzoin condensation reaction. Dear friend, what is condensation reaction? Condensation reaction is that reaction when two molecules react together without elimination of any side product. That reaction is known as the condensation reaction. In this reaction, both the benzaldehyde react together without elimination of any side product and form only single product. Therefore, this reaction is known as the condensation reaction. Next, there is the aldol condensation reaction. This is a very famous reaction in the chemistry, that is the aldol condensation reaction. In the aldol condensation reaction, aliphatic or aromatic aldehydes and ketones containing alpha hydrogen undergo the condensation in presence of this to give beta hydroxyaldehyde or aldols or beta hydroxyketones called ketones. The reaction is known as aldol condensation reaction. Why this reaction is known as aldol condensation? Because the final product contains both the functional group, that is aldehyde, and alcoholic group. Therefore, this reaction is known as the aldol condensation reaction. Suppose this is the one molecule of acetaldehyde, another molecule of acetaldehyde. They condense together in presence of dilute NaOH, that is base. Then it forms the beta hydroxy butyraldehyde. This product contains the aldehyde functional group and hydroxy functional group. Therefore, alcohol and aldehyde both functional groups present in the same product. Therefore, this product is known as aldol and reaction is known as aldol condensation reaction. When we further heat, then there is the elimination of water molecule from this OH and this hydrogen. There is the formation of alpha beta unsaturated aldehyde, that is known as the protonaldehyde. Then another example is two molecules of acetone reacts in presence of base NaOH, then it gives 4-hydroxy 4-methyl 2-pentanone. This is the details about the aldol condensation reaction. Then we discuss about the Clemmensen reduction. Here friends, first we discuss what is meant by reduction. Reduction is that reaction there is the addition of hydrogen or removal of oxygen. That reaction is known as the reduction reaction. This reaction was explained by the Clemmensen. Therefore, this reaction is known as the Clemmensen reduction. In this reaction, aldehydes and ketones will reflux with large excess of amalgamated zinc treated with mercury and hydrochloric acid. Carbonyl group get reduced to methylene group to give the corresponding hydrocarbons. In this reaction, the aldehydes and ketones directly converted into the hydrocarbons, and this reaction is known as the Clemmensen reduction. For example, suppose this is the aldehydes or ketones, or it is the carbonyl group, general reaction. Then when we heat it in presence of zinc Hg, it is known as the amalgamated zinc in presence of acidic condition, and when we reflux, then it gets converted into the hydrocarbons along with the elimination of zinc and mercury. This is the acetaldehyde. When acetaldehyde is carried out, the Clemmensen reaction in presence of ZnHg HCl and reflux, it gets converted into the ethane along with the elimination of zinc chloride and mercury and water. This is the benzaldehyde. Benzaldehyde, when reduced in presence of amalgamated zinc, in presence of hydrochloric acid reflux, it gets converted into the toluene. That is benzaldehyde converted into toluene along with the elimination of zinc chloride and water molecule and mercury. So this is all about the Clemmensen reduction reaction. The next is another reduction, that is known as the Ulf-Kishner reduction. This Ulf-Kishner reduction is the another type of reduction. In this, two scientists explain this reduction, that is Ulf and Kishner. Therefore, this reduction is known as the Ulf-Kishner reduction. Aldehydes and ketones are being heated with the hydrogen and a strong base like potassium hydroxide or sodium ethoxide at 450 to 470 degrees Celsius. Carbonyl group gets reduced to methylene group to give corresponding hydrocarbon known as Ulf-Kishner reduction. Suppose this is the ketone on treatment with the hydrogen, then it produces the intermediate products on hydrolysis. In presence of potassium hydroxide and sodium ethoxide, it gets converted into the hydrocarbons along with the elimination of nitrogen gas. Then acetaldehyde is prepared with the hydrogen in presence of the potassium hydroxide and sodium ethoxide get converted into the ethane molecule. Means the acetaldehyde directly converted into the ethane. This reaction is known as the Ulf-Kishner reduction along with the elimination of the nitrogen gas. Then acetophenone on treatment with the hydrogen in presence of potassium hydroxide and sodium ethoxide get converted into the ethyl benzene along with the elimination of the nitrogen gas as a side product. Then discuss about Mirvin-van der reduction reaction. This reaction is known as the MPV reduction reaction. This reduction was discovered by three scientists Mirvin-van der. Therefore, this reduction is known as the Mirvin-van der reduction, or it is also known as the MPV reduction. Aldehydes and ketones when treated with the aluminium isopropoxide in isopropanol, carbonyl group get reduced to alcohol. This reaction is known as the MPV reduction reaction. Suppose this is the ketone. Ketone on treatment with the aluminium isopropoxide first produces the intermediate product. This intermediate product treatment with dilute H2SO4, it produces the alcohol. That is, ketone is converted into the alcohol. This reaction is known as the MPV reduction reaction. If we discuss the another example of the Mirvin-van der reduction, that is acetaldehyde. Acetaldehyde when treated with the aluminium isopropoxide in presence of the isopropanol, then it produces the ethanol. Means acetaldehyde is converted into the ethanol. The next is the reduction by lithium aluminium hydride. This lithium aluminium hydride is represented as LiAlS4. This is the powerful reducing agent. In this, aldehydes and ketones are reactive with lithium aluminium hydride in ether. Carbonyl group get reduced to alcohol group, use the alcohols. Means these aldehydes and ketones get converted into the alcohol. This reaction is known as the reduction by lithium aluminium hydride. Suppose this is the ketone. Ketone on treatment with the LiAlS4 along with the ether, then this ketone gets converted into the ethyl alcohol. Then this is the acetaldehyde. When acetaldehyde is treated with the LiAlS4, that is lithium aluminium hydride in ether, then it gets converted into the ethanol. Then next reaction, that is the benzaldehyde. Benzaldehyde on treatment with the lithium aluminium hydride in ether, then it converted into the benzyl alcohol. These are the various examples of the reduction of aldehydes and ketones by using the reducing agent, that is the LiAlS4, or it is known as the lithium aluminium. I am very much thankful to all of you for watching this video. If you like this lecture, then you share to your friends and like and subscribe this channel, that is Hydride. Thank you very much.